So this is example 2 of Hardy-Weinberg solving. So we have a population of birds, and the feather color of the birds is determined by a single gene with two alleles. We have big R, which is dominant and is for the red feather phenotype. And we have little r, which is recessive and is for the white feather phenotype. In the population, 9% of the birds have white feathers, which is recessive. Assume the population is in Hardy-Weinberg equilibrium. We want to find the frequency of the big R allele, the little r allele, and the frequency of homozygous dominant individuals in the population. So to solve this, we have p plus q equals 1, and we have p squared plus 2pq plus q squared equals 1. And we know p is the frequency of the dominant allele, q is the frequency of the recessive allele, p squared is the proportion of the population that is homozygous for the dominant allele, 2pq is the proportion of the population that is heterozygous, and q squared is the proportion of the population that is homozygous for the recessive allele. So we know 9% of the birds have white feathers, which is recessive. So 9% is 0.9. I mean 0.09. And so this 0.09 equals q squared, because this is recessive and the proportion of the population that is homozygous for the recessive allele is q squared. So to find q, which is the frequency of the recessive allele, which is little r, we take the square root of both sides, and we get q equals 0.3. And so this is the answer to the second question, which is the frequency of the little r allele, which is the recessive allele. So to find the frequency of the big R allele, which is the frequency of the dominant allele, which is P, we use this formula, which is P plus Q equals 1. We do P plus Q, which we already know as 0.3 equals 1. We subtract 0.3 from both sides to get P equals 0.7. And so we know that that would be the frequency of the big R allele, which is the dominant allele. So 1 would be 0.7, which is P. For the third question, we want the frequency of homozygous dominant individuals in the population. So that would be P squared, because that is the proportion of the population that is homozygous for the dominant allele. So P squared, well, we already know P, which is 0.7. So P squared just equals 0.7 squared. And that equals 0.49. So that is the frequency of homozygous dominant individuals in the population, which is P squared. And that is example 2.